In this video, I'm going to go over some examples of multiplying and dividing radicals. Let's review the basics first. If a and b are real numbers and the indicated roots exist, then the nth root of a times the nth root of b equals the nth root of a times b. Furthermore, the nth root of a divided by the nth root of b equals the nth root of the quotient a over b. An important fact that we'll also use is if n is even, then the nth root of a to the n is the absolute value of a. And if n is odd, then the nth root of a to the power n equals a. Let's see some examples. Simplify each of the following radicals. Starting with part A, root 20, that's equal to square root of 4 times 5. Using the rule for radical multiplication, this is multiplying radicals, we can write square root of 4 times 5 as square root of 4 times square root of 5. Square root of 4 is 2, and square root of 5 is square root of 5, so square root of 20 is equal to 2 root 5. B. What is the square root of 72? That's the square root of 36 times 2. That's equal to the square root of 36 times the square root of 2. And square root of 36 is 6, so we get 6 root 2 equals root 72. C. Minus square root of 300. That's minus square root of 100 times 3. That's minus square root 100 times square root of 3. Square root of 100 is 10, so we get minus 10 root 3. Part D. Let's evaluate the cube root of 32. That's the cube root of 8 times 4, which is the cube root of 8 times the cube root of 4. Cube root of 8 is 2, and cube root of 4 we can't do anything about it, so cube root of 32 equals 2 times the cube root of 4. Part E, let's evaluate the square root of x cubed. That's square root of x squared times x. That's the square root of x squared times the square root of x. Now, square root means index 2, and 2 is an even number, so I'm going to use this fact. If n is even, then the nth root of a to the n equals the absolute value of a. In other words, the square root of x squared equals the absolute value of x. So going back here, the square root of x squared is the absolute value of x, and square root of x, there's not much we can do with that, so the final answer is absolute value of x times square root of x. Part F, what is the fifth root of x to the power 5? Here note that 5 is an odd number, and going back to our fact, when we're dealing with odd numbers, we're going to use the second case of the fact. When n is odd, the nth root of a to the n equals a, which means that the fifth root of x to the 5 is simply x. So, fifth root of x to the 5 is x. G. What is the fifth root? What is the square root of 5 divided by the square root of 20? That's equal to square root of 5 divided by square root of 5 times square root of 4. Notice how square root of 5 cancels with square root of 5. We have 1 over root 4, which is equal to 1/2. H. Let's simplify the square root of w to the power 8 over 169. That is, using the division rule for radicals, that's the square root of w to the power 8 over the square root of 169. That's equal to the square root of w to the power 4 squared over the square root of 13 squared. For the square root of w to the power 4 squared, notice that the index is even, so this comes out as the absolute value of w to the power 4, and square root of 13 squared is equal to 13. But w to the power 4 is w raised to an even integer. It could never be negative, and in this case, the absolute value is redundant. So we can simplify our answer by writing w to the power 4 over 13. Part I, let's simplify the cube root of m to the power 9 over 8. Again, using the division rule for radicals, we can write cube root m to the power 9 over the cube root of 8. That's the cube root of m cubed, all raised to the power 3, divided by the cube root of 8. And the cube root of m cubed cubed is m cubed. Notice we don't have to worry about absolute values here because the index is equal to 3, which is odd. And the cube root of 8 is 2. So the simplified answer of the radical cube root m to the power 9 over 8 is m cubed over 2. Finally, I want to say a few words about why is it that the nth root of a to the n equals absolute value of a when n is even. I'm just going to illustrate this by means of an example. Let's look at the square root of 9. The square root of 9 is equal to the square root of 3 squared. But also, the square root of 9 is equal to minus 3 squared. So if we assume that when n is even, the nth root of a to the n equals a without any absolute values, then we would get the following. The square root of 3 squared would equal 3, and the square root of minus 3 squared would equal minus 3. Since we have a sequence of equalities, we have 3 equals minus 3, which is nonsense. That is a contradiction. So when n is even, it is false to assume that the nth root of a to the n will always equal a. How do we remedy the problem? Well, we apply the correct formula. The nth root of a to the n is equal to absolute value of a when n is even. Let's see how that fixes the problem. Square root of 9 is the square root of 3 squared, which according to our identity, the true identity, the correct identity, is the absolute value of 3, which is equal to 3. And square root of 9 equals the square root of minus 3 squared, which according to the correct identity is the absolute value of minus 3, which also equals 3. Now everything makes sense and everything is equal.